Alright, so this is the recording for the second practical, and that is titled Estimation of Reducing Sugar of Banana by DNS or Dinitrosilicic Acid Method. I will try my very best to proceed with one or two parts, but if unable, then I will do it with more than two parts. So this practical, we are going to learn about estimating the sugar concentration, or rather the reducing sugar in the banana. So we're going to take the banana, do some processing where we extract the reducing sugar, and then the reducing sugar will be treated or reacted with DNS reagent, where color changes could take place, and these color changes can be measured in accurate or quantified by using spectrophotometer at a specific wavelength. So you can measure it by absorbance, and by using standards we can then build standard curves. Standard curve is a graph that we can use to determine the unknown, which is the absorbance of the banana, and we can obtain the concentration of the sugar by using this standard curve. And to build this standard curve, we are going to use glucose. So glucose will be used at various concentration to determine their respective absorbance when reacted with DNS, just like the unknown in the banana. So once done, you will have absorbance of the various concentration of glucose. Okay, then you get spots in the graph where you can build this standard curve. Okay, so it's basically matching the standard curve with the unknown absorbance in the banana, and we can find out its corresponding concentration, and that's what we are going to use. The application of this standard curve will be based on this Beer-Lambert's law. So I have to take another a description or explanation about Beer-Lambert's law, spectrophotometer, for you to understand better what I have just explained in detail. But for this video, I only will describe the experiment itself. Again, since we cannot do the experiment in the laboratory, what we are intending to do is to have a thorough explanation on the experiments, as well as showing you some videos relevant to this experiment itself, where can determine the unknown reducing sugar in banana by using the DNS assay. So for the videos, I have a number of YouTube videos. The first one has been described is on the use of micropipette. A micropipette is a simple equipment where it can deliver various volumes that you are intending to deliver. For instance, you can deliver, say, 550 microliter of water into the test tube, and this is a very small volume, and hence using a measuring cylinder will not be accurate. So best to use a micro pipette. So please watch this video that has been done by me some time ago, and it explains very well the use of micro pipette. Another video is relevant in terms of the chemistry or the principle, the mechanism of the DNSA reaction. It explains how the changeover of color takes place, but it's not only qualitative. Whenever there is a reducing sugar where it has the carbonyl group to be exposed, then it will react to this DNS reagent, therefore can be utilized and measuring using a spectrophotometer, and hence it can become from qualitative to quantitative. So please watch this video. Next one is another video, and this video is actually done by Malaysian students, and it's very much similar to the this practical that we are doing. Therefore please go through this video. Only certain nitty gritties are to be different. For instance, I've already explained the absorbance is different compared to what we are doing in our experiment, but overall, even though slight difference in terms of the absorbance been set for the spectrophotometer, but it is still able to absorb maximum either 540 or 510. But overall, it will give you an idea what is done in the laboratory for this DNS assay. And the last YouTube video is also very much important, where it gives an idea of how to use the Excel, Microsoft Excel, in building the standard curve. You see, when I was a student, I used a graph paper to build the graph for the standard curve. Once I already know the relevant absorbance and concentration, so the graph will be like this. But in order to find out the unknowns concentration, I had to extrapolate. They call it extrapolate. But these days, there is no need for extrapolating, like this. All you have to do is, nowadays, you determine the equation y equals mx plus c, and then you just replace y m if there is no c, because it's going through the origin, then it'll be y equals mx. Therefore there is no need for c, and you just need to find out x where it is extrapolating. So no need to use the graph paper. So please go through this video in understanding better how been shown to build the Excel graph. Now we move to the actual practical itself, where you cannot do in the laboratory, unfortunately. This practical is about estimating the reducing sugar found in one or two sample. In the laboratory, sometimes we take or purchase two types of banana, and we determine the reducing sugar, where half of the class will work on banana A while the other half work on banana B. So before we proceed in the experiment, you are required to prepare certain solutions in this experiment. you need to prepare the DNS reagent. So how to prepare the DNS reagent? You have to prepare it in 1% NaOH. I hope you understand how to prepare 1% NaOH. Normally, you have to weigh 1 gram of solute NaOH, sodium hydroxide. Solute means it's in powder form. Then you take a volumetric flask. Okay, I hope you know what's a volumetric flask. Try to bring in the solute inside. This is then there will be a meniscus or graduation where indicates it is has been put there. You must use a 100 ml volumetric flask, and then you pour water until this line, and then followed by followed by covering the container, and then tilting it upside down several times. That's how we mix it, up and down until it's completely mixed. The solute is dissolved. Therefore, you already prepared this 100 ml 1% NaOH. Right, so that's a bit of understanding since you are not in the laboratory. So let's look at what is done after that. So you have to weigh 200 milligram, 1 gram, 50 milligram of sodium sulfate, and also use that 100 ml of 1% NaOH to dissolve all this exactly. Okay, but also they have given some precaution. Try to add sodium sulfate only when need to use this DNS reagent because it's not stable. Right, so next one is 40% Rochelle salt. This one is done by, they already made it easier for you. 40 gram of potassium sodium tartarate or Rochelle salt, and bring to 100 ml. This is actually same as just now. You again have to use a volumetric flask, which is 100 ml. Okay, you drop the weight 40 gram, and then add water until the level where it indicates 100 ml, and then cover with a stopper and tilt it upside down many times until it is dissolved. So this is how we prepare solution. We now move into the actual experiment itself. Looks like I can do this in one part. So let me try to finish the whole explanation on this practical by completing it in one video itself. So the procedure is you take 1 gram banana, okay, freshly purchased, okay, fresh sample, and then put in liquid nitrogen. Normally we use a pestle. If you don't understand what is pestle and mortar, uh, pestle and mortar is just something to hit on it. Okay, put the 1 gram sample, put liquid nitrogen. This need to be done with caution because it's quite hazardous liquid where it can cause, if it drops on your fingers, it can freeze your fingers, and if you have accidentally tapped your frozen finger, uh, the consequences is quite worrying. It's like in the Terminator movie. Okay, so that's what we are doing. We put the banana, when we put liquid nitrogen and then hit it with a mortar, it will break, and hopefully it breaks the cell membrane and expose the inside content where has the reducing sugar. Okay. Next, you transfer. Hopefully, it's a bit like what do you call, in semi solid form already with viscous solution. You transfer now to normally we use a centrifuging tube. Okay, this is 40 ml centrifuge tube. We add 8 mol 8 mil of 0.5 molar NOH. Okay, and also this sample inside, so it should be like that with the substance here, presumably with the reducing sugar in it. So we treat it, and then you're supposed to vortex. You see, in the laboratory we can't use spoons like what we do to mix the tea or coffee once we put the powder, but in the laboratory we vortex it. It will create a swirling effect, or whirlwind kind of effect to mix the uh, whatever needed to be mixed, okay, without the use of a spoon. If you want to understand better what's the how the vortex instrument is used, go and watch this video. What's next? We already mix it. We need to centrifuge it at 5500 revs per minute for 20 minutes. And also, because we are using something which is organic, reducing sugar, we don't want it to be broken down. We maintain at 4 degrees Celsius. So please watch this video on the method of centrifuging, so you understand what is going to happen is, once it's been centrifuged, let me use back this drawing. Okay, right, once it's been centrifuged, once you take it out from the centrifuge equipment, you will have something like this. Okay, this is the bottom sediments, the banana material that you don't want sediments at the bottom, because it's been spun at a very high speed. It will come to the bottom, and then the wanted material which is in the liquid, probably the reducing sugar already dissolved in the liquid, and this is referred as supernatant. Okay, and we are to collect the supernatant, and if required, sometimes the debris could be still present here, so maybe we also need to, not sure whether you've done in school, you have done put a filter paper here, eh? And then you can pour the whole thing, and then collect in drops in a beaker. Okay, so but normally in the laboratory, I just tilt it into a beaker. I will not have this come with the supernatant. Only the liquid will come out. Therefore, sufficient. No need to do filtering with filter paper. But if need to, please go ahead. And then let me clear all this. Okay, it's great to use this drawing tool. Okay. Okay. So, assuming now you have the supernatant, you are to neutralize the supernatant with acid. So you can also put a pH meter probe and then slowly drop the acetic acid until it become pH 7. But if you don't want to use a pH meter, just use a paper litmus litmus paper with indication it's pH 7, also roughly is okay. Okay, so that's done, and then you are to take this one, maybe assuming you thankfully you got some 4 ml finally. So they want you to take into different say test tubes. uh, say 3 lah. Say you take zero point 0.5 ml, 1 ml, say another one 2 ml. Okay, so because they say you can take either 1.5 until 3 ml. So if you do this 0.5, 1 and 2, they also said you have to equalize until 3 ml. So you have to add here 2.5 of water. Here must add 2, right? And here must add 1 ml of water. So this is your reducing sugar from the banana which you extracted. Then you add this. So total will be 3 ml. This is all the unknown but different concentration. Okay, so the next step is you add 3 ml of DNS. So if you have this much, now you add all 3 ml. Okay, heat the content in water, boiling water bath. Okay, how do we do that? Go back to show this. Okay, very useful. Can use that again. Maybe use a different color to draw the, say I put this. Okay, I put this into a beaker that has water, and then this is, I place it on what is known as a hot plate. Okay, right, hot plate, and here I pour water outside of it, and our supernatant is inside. Okay, or rather these tubes are inside there. Maybe I put A here, and then B and a C. Okay, and it has a mechanism to adjusting knobs. Just adjust the heat, maybe at 5 or 6, and then heat will start to come. Okay, and the water start to boil, and it will transfer the heat to the test tube, and this is done for 5 minutes. Okay, once it is heated for 5 minutes, and then when it's still warm, add the Rochelle salt. Okay, and take out the test tubes, cool it. Find out how to cool very fast. It has to be very room temperature for you to read the intensity at 510. So what is this read intensity at color 510? You obviously need to use a spectrophotometer. For understanding of a spectrophotometer, you have to watch a video, or I will brief you later on that Beer Lambert and also spectrophotometer principles. Okay, right. So you have to do that. Once our unknown of ABC is already ready, treated with DNS, readily read on the spectrophotometer, now you have to build this standard of glucose. You have various concentration of known glucose concentration, and to find out their absorbance after treating it the same way that you have done the unknowns. Okay, this is to build the standard curve. So they say prepare 10 milligram per ml of glucose. Maybe you can use this also. You weigh 10 gram, and then again using a volumetric flask. Hopefully you use a 1 liter flask. Put the 10 gram inside, add water until the meniscus, shake up and down, then you get 10 gram of 10 gram per liter concentration of glucose, which is equivalent to 10 milligram per ml of glucose standard. Okay, right. So you have the stock, which is 10 milligram per ml glucose. You are to make into this desired concentration 0.2 until 1 milligram per ml. How to do? I leave it up to you, because you need to do some calculation. All I can give you is the hint. You have to use this equation whereby M1V2 before dilution and after dilution. So you are to make total of 10 ml from this 10 milligram per ml until it become 0.2, 0.4, 0.6, 0.8, 1 milligram per ml for each one, with the end dilution to be up to 10 ml. Find out how much you need to use the stock, and also how much of water to be used. Okay, right. So maybe this also can be found out. Okay, right. So do that, and then they say here, go back to step 8 to 11, but not use all the 10 ml, only use 3 ml for each. So let's look at that. So you have 6 test tubes. You again add 3 ml to each, heat the content using what is being done here. Put all the 6 test tubes there, and then after 5 minutes, while it's warm, you add 40% Rochelle, cool it somehow, then determine the absorbance reading at 510. Okay, right. So once you have all this reading to be put, and also perhaps you can also determine the corresponding absorbance. What is the absorbance after you complete the experiment? All these, A, B, C, D, E, F, all done. Okay, so hopefully by having all this, you can build the graph of absorbance over concentration of glucose. So hopefully you take the A, B, C, D, E, F, and build that, and okay, hopefully it's very good. Then get the computer to draw the line, and then determine what is y equals mx, or even up to mx plus c. And this equation you can then use to determine the unknowns, because unknown, all you already know the absorbance, so you use it to find out what is x, I think, yeah, x. So you will know its concentration. At the moment you have its absorbance. You use this equation to find out what is the concentration of the unknown. Okay, so they call it unknown. So you have A, B, C, A, B, and C unknowns. You will get the concentration, but here's the thing, you have three unknowns, but bear in mind these are having different dilution factors, because here, like one add with two, what is the dilution factor? You need to multiply, maybe this one no need, also need to multiply, then all will be same concentration. Maybe you can get the average to determine the final concentration for reducing sugar in the banana. Okay, so that's it in terms of conducting the experiment all by online. I will try to make another presentation on the use of spectrophotometer, Beer-Lambert's law, others as well, for more understanding of this practical. Um, you to do this in online, therefore please watch all the videos given to you here, and I will give a hypothetical result for the purpose of doing the standard curve, and also perhaps also A, B, C, or even D on the unknowns, values for the unknown absorbance wise, and for you to find out the concentration, and hopefully you end up with one answer of average value for the reducing sugar in the banana. So in the report also include the answer to these questions. You are to contact the technical officer and find out what is the micropipette used in our laboratory, spectrophotometer brand model, and then find URLs of videos, suitable videos, and include. The reason I asked to include is for you to watch those videos to understand. Forgive me, this is supposed to be 3, 4, and 5. Okay, typo error there. So find out about this question, answer to this question. I'm not going to give you hints or answers. You're supposed to do it also, as well as this. Then why is it necessary to neutralize? Okay, also find out based on the reactions, and then also very interested to give you a challenge on difference between blank and also blank and control. Okay, what is the difference between blank and control in biochemistry? It's very important to know. Okay, I didn't talk about it here, but it has something to do with the use of spectrophotometer. Well, that's it in terms of this practical, that is estimation of reducing sugar of banana by DNS method, and it looks like it introduces the use of standard curve, which also will be applied in the protein determination method, such as Bradford, Buret, and other methods. We normally use a standard curve. I therefore end my presentation for this practical, and this will be uploaded in YouTube.